Hello everyone, welcome back to Let's Unbound. So yes, we are in 2.2 of AP Precalculus, one topic at a time. And today we are going to explore change in linear and exponential function. A very quick review. As usual, three-tier problem solving will be there. So let's get started. So first we know this, what is linear function, how the exponential functions will look like. So in this change in linear and exponential function, so we will understand the differences, how the values will change in linear versus exponential. And this will be the very important thing whenever you are making a model or you are identifying a function. So linear function, it's a mathematical relationship where the graph is a straight line. It has a general form, f of x is mx plus b. We have already come across linear function. Exponential function is your independent variable will be in the exponent. Okay, not every exponent kind of function is not exponential. Only if your independent variable is at the exponent place, then it is exponential function, right? And this graph will be a curved one. Yes, we will explore more about this in this unit. So now, in previous subunit, we have come across arithmetic and geometric sequence, right? Now, linear function and arithmetic sequences are much interrelated. So in linear function, this is the slope-intercept form. Okay, actually we'll write mx plus b, but for a convenience, for easy comparison, I write b plus mx. Anyways, this is slope-intercept form. Arithmetic sequence, we learned a formula. How to find a general term, first term plus d times m. So this one. And if you write a linear function in a point slope form, it will look something like this, right? y1 plus m into x minus x1. Arithmetic sequence, like what is this formula? This is also general formula, but from any number, we always start with the initial term, right? This is like any term, and you have to make a general form, and we will go with that. So even in the way we structure the equation, the linear function and arithmetic sequence are much interrelated. That is one common. Here also we will have constant rate of change. Here we have common difference. Both are just finding differences, right? So that's the interconnection. But there is some differences also there. So they are mostly interrelated. Okay, the graph plays an important thing. This is sequence. Arithmetic sequence, if you graph it, you will get a scatter plot, like a discrete points, right? It's not a continuous connected curve. But this is a function. Linear function, yes, it's exactly same points, but it is interconnected and it's continuous smooth graph. So that's the difference. This will be discrete, this will be continuous, because we don't have first term, we can say second term, we can't say. You can't say 1.5th term or 3.7th term, right? So that's why there is a gap, right? So that's the important difference. Now, exponential functions and geometric sequences are also much interrelated. Exponential function looks like this: a b power x, that x is only for b, that exponent. And geometric sequence can be written like this: initial term, a is initial term, r power n minus 1. Shifted exponential function is, actually this is x minus x1. y1 into b power x minus x1. And if you want to find geometric sequence from any term, like any kth term, not from the initial term, gk into r power n minus k minus 1. So these things we can relate for exponential function structure and geometrical sequence nth term structure, right? So whenever we model and manipulate exponential function, we depend upon the knowledge of geometric sequence. That's why I'm showing this. And here, the graph, as usual, this is geometric sequence graph. It will have discrete points and same thing, but it is a continuous graph. So it's continuous graph. This represent a function. Okay, exponential function. That's a simple thing. Now, let's solve some questions on this. It is known that f of x is linear and it passes through the points. Write an equation for the function. Next, it is known that f of x is an exponential function and it passes through 2 points. Write an equation for the function. Right? So let's start. Let's solve one by one. Linear function means, you can take 2-point form or mx plus b, any form you can pick. So I'm going to pick y minus y1 is m x minus x1. So your x1, y1 is any point. I'm going to pick this. And m, how will you find? If you know 2 points, you can find m. So m is y2 minus y1, x2 minus x1. Let me mark this as x2, y2. And let's solve for m. So what is my y2? Minus 2. Formula has a minus. Y1 is 4. x2 minus x1, 5 minus 1. So minus 6 by 4, which is minus 3 by 2. And you can plug in y minus 1 equal to, your m is minus 3 by 2, x minus x1 is 1. You can leave as it is, or if you want to write it as a function, right, better way, you have to write f of x. So let me tell you, make y as a subject. So y minus 1 is, distribute the minus 3 by 2, minus 3 by 2 x plus 3 by 2. See, I did a mistake. Actually, here 4 will come, right? Y minus y1. So this minus 4 will shift here. So y equal to negative 3 by 2x plus 3 by 2 plus 4. When you simplify these, it will become 11 by 2. And write it as a function, not like a just equation. So you put f of x equal negative 3 by 2x plus 11 by 2. That's simple. So this is part A. Very basic point slope form I have applied. I find slope and then I substitute in the equations. Then you represent as a function form. Okay. Now, B part of question 1. It is known that f of x is exponential. So what is the exponential general structure? An initial value, let it be a, into b will be raised to the power x. So your exponent will be the variable x. And it passes through the points. Okay. So 0, 3 means this is initial value. So you can directly put a equal to 3, or you can plug in and solve for it. So 0, 3, if you plug in, 3 equal to a into b power 0. Right? This is your x, y. And b power 0 means 1, you got a equal to 3. Now your function is half done. You got f of x is equal to 3 into b power x. If you find b, then it's complete. So use the next point. F of x, okay, I'm using 3, 24. So in place of, if this is your x, this is f of x. So 24 equal to 3 into 3 power, sorry, b power, right? B power 3. And simplify solve for b. So if you cancel out, it's b cube equal to 8. And this represent b equal to 2. Very simple solving. So yeah, I got my b and the function is done. F of x is equal to 3 into b is 2 power x. Okay, don't put 6 power x because you can't combine this, right? 3 into 2 power x is our function. Right, that's simple, and we are moving to question number 2. Mrs. Lopez has been planting apple trees in her orchard for many years. The number of trees planted each year follows an arithmetic sequence where the first year is year 1. She planted 18 trees in year 4 and 66 trees in year 16. How many trees did she plant in year 10? So it's an arithmetic sequence, but I don't know what is the initial trees planted, like initial value of the trees. So that main thing is not there. And every year, how many trees are added because it's arithmetic, right? So that is also we don't know. Let's go with our information available. Year 4, 18 trees. So fourth term is 18 and it's arithmetic. In arithmetic, general term will take a plus n minus 1d. So if you want a third term, a plus 2d. So a4 you can write a plus 3d equal to 18. Right? And then 66 years in year 16. So a16 is 66. So you can write a plus 15d, right? A plus n minus 1d equal to 66. You find your a and d from this. Then you can find any, for any year, you can find the number of trees. How will we do this? You can simply use substitution method or elimination method. I'm going to use elimination here. Let me eliminate this a by subtracting throughout. So this will cancel. 3 minus 15 is minus 12d. 18 minus 66 is minus 48. And d is 4. So every year 4 is getting added. Right, but I want a also. A equal to 18 minus 3d. How I got this from this, right? And I know d now. 18 minus 3 times 4. 18 minus 12. A is 6. That's it. So in 10th year, it's easy to find. So let me find the general term. An equal to a plus n minus 1d. Your a is 6. Common difference is 4. So it's 6 plus 4n minus 4. 4n plus 2. This is the whatever the year, if you want the number of trees, you can use this. So now I want 8n. A10 is 4 times 10 plus 2. 40 plus 2, 42. So there will be 42 trees in year 10. Right? That's simple. So we just need a simple manipulation technique here. And we are moving to last question. Question number 3. A rare species of fish in a lake is increasing in population according to a geometric sequence. In year 1, there were 40 fish. By year 3, there were 160 fish. How many fish there will be in year 7? So same like what we did in arithmetic sequence in previous problem. Here we are dealing with geometric sequence. In year 1, there were 40 fish. So initial value A is 40. Year 3, it was 160. And I want to remind you what is general term of a geometric sequence. Initial into common ratio power n minus 1. Right. So third year means what? A3 is A into R power 3 minus 1. I know A, which is 40 into R power 2. Okay, this is A3 40 R square as an expression, but I know what is A3 actually. It is 160. So 40 R square equal to 160 you can put, and you can solve for R. R square is 4, like 40 and 160 if you solve it, and R equal to plus or minus 2. Since it's increased, it will be this rate will be, common ratio will be positive 2. So R is 2, and that's it. I got A and R. So now general term for this kind of population is AN is A into R power. R is 2, N minus 1. Okay, so if you want, you can simplify this. Otherwise, let it be. Now we can go for the question. How many fish will there be in year 7? So what is your A7 is the question. Okay, so A7 equal to 40 into 2 power 7 minus 1. And 40 times 2 power 6. 40 times 2 power 6, I think it's 64. And when you multiply, you will get, let me check it quick. 40 times 64 will give you 2,560. Right? So there will be 2,560 fish in year 7. And can you see the difference? By year 3, it was just 160. And that was a tremendous growth. This exponential function will always make. It starts with year 140 and it's 160 and 2560, right? But in arithmetic sequence, you can see the growth will be like constant, it will be slow. But here it will be a tremendous growth. Right, and yes, here is your bonus question. A bacteria culture triples in size every hour. Initially, there are 200 bacteria. Write an equation to model the number of bacteria after X hours. You have to model it. Very simple. How many bacteria will there be? So you can rewatch the previous question 3 if you got any doubts here. Is this linear or exponential? This question is so simple. You can answer C first and explain the change, right? So when you're explaining the change, you can say constant rate, or if it's multiplying by a ratio, you can say proportionally. These are some exact words you can use here, right? So drop your answers and also your feedback suggestions in the comment box, right? And here is the wrap for today's video. Thank you so much for joining and learning with us. I will be meeting you in next video 2.3 very soon. Until then, keep learning, keep practicing. So gentle reminder to join Let's Unbound Student Community WhatsApp group. You can scan the code that is in the screen. Right. Thank you. Stay curious.